एवरीवन, वेलकम बैक टू DBMS रिवीजन सीरीज। आज हम DBMS का एक बहुत इंपॉर्टेंट टॉपिक समझेंगे जो एग्जाम और इंटरव्यूज दोनों के लिए इंपॉर्टेंट है। वी आर टैकलिंग यूनिट 4 टुडे, स्पेसिफिकली ट्रांजैक्शन स्टेट्स एंड द लाइफ साइकिल। I know, the SPPU MCA 2025 pattern exams are right around the corner. थोड़ी एंग्जाइटी तो होती है। डेटाबेस मैनेजमेंट सिस्टम्स कैन सीम अ बिट इंटिमिडेटिंग, बट लिसन टू मी, टेंशन बिल्कुल मत लीजिए। Today, we're going to decode these technical concepts into such simple language that you'll walk into that exam hall full of confidence, ready to score full marks without mugging anything up. So let's dive right in.
Okay, so real quick, here's our game plan for today. We'll start with the relatable GPay crash problem, then clearly define what a transaction actually is. After that, we'll look at the 5 specific states a transaction goes through, map them out on a lifecycle diagram, and see how it all works. Finally, we'll cover things purely from an exam point of view and wrap up with a quick revision summary.
Let's jump right into Section 1. Welcome and the GPay crash problem.
Picture this. You're chilling in the canteen with your friends. You initiate a payment from your phone, enter your PIN and hit enter. Boom! The screen just keeps spinning. Then you get a message saying your money was deducted, but your friend looks at you and says, "Bhai, मुझे तो कोई notification नहीं मिला." We've all been there, right? पैसा कट गया, पर गया कहाँ? Or maybe you're at an ATM, you hear the cash counting sound, then an error pops up. Your balance drops, but no cash comes out. Instant panic, right? Well, don't panic. This is actually a brilliant, secure, fail-safe mechanism built into the DBMS, and understanding this everyday crisis is exactly why we need to learn about transaction states.
All right, moving to Section 2. What is a transaction? Let's clear up the absolute basics first.
Let's keep the heavy technical jargon aside for a minute. A transaction is simply a single logical unit of work that accesses and possibly modifies the contents of a database. Think of it like this. When you're shopping online and you finally click Pay Now, that single click kicks off a transaction. But behind the scenes, there are actually multiple mini-steps happening. It checks your balance, deducts the amount, and then adds that amount to the e-commerce website's account. Now, the DBMS doesn't look at these as separate little tasks. It bundles them all together into one single unit. The rule is simple. Either the whole unit passes or the whole unit fails. There's literally no middle ground.
So why are these transactions so absolutely crucial? Well, first off, they ensure data consistency. In a banking system, the data has to be 100% accurate. एक रुपए का भी हिसाब इधर-उधर नहीं होना चाहिए, right? Secondly, it handles concurrent users securely. Imagine thousands of people trying to book a Tatkal ticket on IRCTC at the exact same millisecond. Transactions make sure your booking doesn't get tangled up with someone else's. And third, they are lifesavers when it comes to recovering from system crashes. They ensure that even if the power goes out, your money doesn't just vanish into thin air.
Now for the main event, Section 3, the 5 states of a transaction.
These are basically the 5 heroes of our story today. We have the active state, the partially committed state, the failed state, the aborted state, and finally, the one we always want, the committed state. As your senior, I highly recommend locking these 5 exact terms in your mind right now. We're going to take these exact 5 building blocks and create the complete workflow diagram that's going to fetch you full marks in the exam.
Which brings us to the climax of the concept. Section 4, Lifecycle Diagram and Working.
Let's walk through the happy path first, the success path. You place that online shopping order. The second the process starts, the system instantly jumps into the active state. Processing is happening. Then, when the database updates in the main memory, like the RAM, saying the item is sold, it moves to the partially committed state. Pay close attention here. It's called partially committed because the data hasn't been permanently saved to the hard disk yet. But once that data is permanently written to the hard disk and your order is rock-solid confirmed, the system slides right into step 3, the committed state. Boom. Transaction done and successful.
Let's cement this with our ATM example. You insert your card, type in 500 rupees. While it's processing, that's the active state. The machine verifies everything with a bank server and updates the main memory. That's your partially committed state. And the moment that cash physically lands in your hand and you get the SMS saying your balance is updated, congratulations. The transaction is fully in the committed state. Once data is committed, it's permanently locked into the database forever.
But, life and servers aren't always perfect, so we must understand the failure path. Imagine that high-stakes IRCTC TAT call booking. Payment is processing, so you're in the active state. Suddenly, the server crashes. The moment the system realizes this transaction cannot be completed, it pushes it into step 2, the failed state. The system knows there's a problem.
Your ticket isn't booked, so to protect the database from getting corrupted with half-finished data, the DBMS triggers a rollback. It wipes away those incomplete changes and sends the transaction straight into the aborted state. Let's bring back our GPay crash example from earlier. You were in the active state, trying to pay. Suddenly, your internet drops or the GPay server goes down. The system immediately hits the failed state. Now, the system thinks, wait, I can't just deduct the user's money, not pay the shopkeeper, and leave the balance hanging. That's not right. So, the recovery manager steps in, rolls the whole transaction back to zero, and aborts it. That's exactly why, when you get that deducted money refunded 24 to 48 hours later, it's because the DBMS successfully rolled it back to the aborted state to keep your money safe.
This perfectly illustrates the ultimate golden rule of databases. Every single transaction in the world ends up in one of two final states. Yato, it passes completely and becomes committed, meaning 100% success and your data is permanently saved. Or, if there's even the slightest hiccup, the system fails it and drops it into the aborted state, meaning the transaction is canceled and the database is rolled backward to its pure previous state. It's this strict binary logic that keeps our complex banking networks so incredibly secure.
All right, students, time to get super focused. Section 5, Exam Point of View. This is my favorite part, and honestly, the most crucial for your SPPU MCA exams. Take this pro tip from me, straight from our professor's mindset. Always draw the lifecycle diagram using a pencil and label all state transition arrows clearly. Look, when an examiner is grading papers, they literally do not have the time to read every single word. Their eyes dart straight to your diagrams. If you have a neat, pencil-drawn diagram where the arrows moving from active to partially committed to failed and to aborted are crystal clear, the examiner practically decides to give you maximum marks right there. A great diagram shows absolute purity of concept.
So, keep this exam checklist in mind. Your answer must have these three things. Number 1, that accurate diagram we just talked about. Number 2, explain each state in just 1 or 2 simple lines. Don't blindly memorize jargon, write it in your own simple words. And number 3, this is the magic trick, use a real-life example. Most students will just write the textbook definitions. But if, right below your diagram, you explain an ATM withdrawal or a GPay server crash using these specific states, your paper is going to stand out from the entire classroom. Practical knowledge always gets heavily rewarded.
Let's wrap up this excellent learning session. Section 6, Quick Revision Summary.
Let's do a super rapid-fire recap of the 5 stages to lock this in. Active state, processing has started. Partially committed state, the RAM has done its job, just waiting for the final hard disk save. If the system is good to go, we hit the committed state. Data is saved forever, no going back. But if an error or a power cut happens while active or partially committed, we drop into the failed state. And finally, when the system's recovery manager reverses the data to prevent any damage, we call that the aborted state. Everything is rolled back. Bas, itna hi concept hai.
I really hope that after watching this, you're feeling totally confident about transaction states and their life cycle. जब एग्जाम में ये क्वेश्चन आए तो प्लीज इस टॉपिक को फोड़ आना बिना किसी टेंशन के. बेस्ट ऑफ लक फॉर योर SPPU MCA एग्जाम्स. आई नो you're gonna excel. अगर वीडियो हेल्पफुल लगी हो तो लाइक, शेयर एंड सब्सक्राइब जरूर करना. Keep learning and keep growing. And before you go, think about this. If our systems didn't have these exact transaction states, would the entire concept of digital currency and online banking even be possible today? See you in the next explainer.